Welcome to the third session. Today we'll discuss on the topic Avogadro's law. So in this Avogadro's law, we will try to understand the relationship between volume and mole. And the learning objectives for today's lesson is, and we'll discuss Avogadro's law and try to also build relationship between mole and volume. When mole here represents number of particles, and after that we will also discuss molar volume, which is very much related to Avogadro's law. So by completing these three learning objectives, we will get a clear picture of Avogadro's law. So in this Avogadro's law, we'll try to build relationship between volume of the gas with the number of moles. And after that, we'll also try to understand the mole here would represent the number of particles. Particles here would mean atoms, molecules, electrons, ions, etc. But we will only consider atoms and molecules. And we have also learned in our previous lesson that a mole will contain 6.023 times 10 to the power 23 number of particles. So this number is what we call it Avogadro's number or Avogadro's constant. The Avogadro's law states that equal volume of any gas contain equal number of particles. Equal volume of any gas will contain equal number of particles. For example, let us consider three gases here: oxygen, hydrogen, and nitrogen gas. Let us assume that we are going to take a container, and inside that container we are going to fill the respective gases. So here we have oxygen gas, and in this second container we have hydrogen gas, and in the third container we have nitrogen gas. So keep in mind that all this volume of the container, they are of same volume, or they are of equal volume. So equal volume of oxygen, hydrogen, nitrogen gas are filled in the boxes. So now if we try to count the number of oxygen molecule, number of hydrogen molecule, and also count the number of nitrogen molecule, we will find that they contain equal number of particles, or they contain equal number of molecules. Now there's one important term we have to bear in mind, that is molar volume. So molar volume is the volume occupied by 1 mole of a gas. So molar volume is a volume occupied by 1 mole of any gas. 1 mole of any gas. And it says that 1 mole of any gas will occupy 22.4 liter of volume. So once again, 1 mole of any gas will occupy 22.4 liter, and that is what we call it molar volume. Okay, so from molar volume we got to understand that, we got to learn that 1 mole of any gas will occupy 22.4 liter. So this is what we have learned from molar volume. That is, 1 mole of any gas is going to occupy 22.4 liter. So let's consider a few examples. Let us say we have 1 mole of carbon dioxide molecule. And let's try to find out its volume. And according to the molar volume, we will find that it is 22.4 liter, which 1 mole of carbon dioxide is going to occupy. And let's take the second example. Again, we're going to take 1 mole of oxygen gas, 1 mole of oxygen gas. And again, if you measure its volume, so again it's going to occupy 22.4 liter. Let's take the third example. 1 mole of nitrogen gas. And if we measure its volume, it's going to be same, 22.4 liter. So this is what molar volume explains. And now let us relate the molar volume with Avogadro's law. So according to Avogadro's law, it says that equal volume of any gas is going to occupy equal number of particles. So we have learned in our previous class that in 1 mole of any gas, it contains 6.023 times 10 to the power 23 number of particles. So with this concept, let us look at the first example. 1 mole of carbon dioxide gas, according to this concept, will contain 6.023 times 10 to the power 23 number of carbon dioxide molecules. So likewise, even for the second example, 1 mole of oxygen gas will also contain 6.023 times 10 to the power 23 number of oxygen molecules. And same goes to the third example, that is 1 mole of nitrogen gas will also occupy 6.023 times 10 to the power 23 number of nitrogen molecules. Now that we have learned, let us recapitulate the lessons that we have learned from the Avogadro's law. So once again, Avogadro's law will give us relationship between volume and mole, number of particles. So this is what Avogadro's law states. And we have also found, and we have also understood the relationship between mole and volume. And then we also looked upon molar volume. So with this, we are done with Avogadro's law.